For part A, we're trying to find the average rate of change from x equals -1 to x equals 1. To start this, we might want to write the ordered pair for the point at x equals -1 and the ordered pair for the point at x equals +1. So to do that, I'll have to plug a -1 into my function to figure out what its output is. Alrighty, so after plugging that in, I know that with an input of -1, I'll have an output of 5. And with an input of +1, I'll have an output of 3. Cool, so now I have my ordered pair, so I can find my average rate of change. Remember, average rate of change is the slope between 2 points. It's the slope of your secant line. So average rate of change is equal to the slope of our secant, which is found by doing f of b minus f of a all over b minus a. It's your slope formula. So in this case, it will be, we can say that this is like x1, y1, x2, y2. So we'll say 3 minus 5 over 1 minus -1, which would give me a -2 over a +2. So my average rate of change is a -1. For part B, we're writing the equation of a secant line that corresponds with what we just found. So we'll need the slope of our secant line, which is your average rate of change, which we found to be -1, and we'll need a point. It doesn't matter what point you use, you're going to plug it into the point slope form. Y minus y1 equals m times x minus x1. I'm going to pick the points 1, 3 because it has less negatives. So the equation for my secant line will be y minus 3 equals -1, because that was the slope of our secant line, multiplied by x minus x1, which was 1. And I can stop there.